Good afternoon, everybody. Welcome on behalf of my flow colleagues. I'd like to welcome you to this webinar on flow and transport modeling, looking at the tools. It's being offered in the context of the Flow project, an EU Horizon 2020 project that's running from 2015 until 2018. And we've scheduled 90 minutes for today's webinar, including questions, so we should be done at 3:30 Central European time. And just so you know, we're live. This is taking place on Wednesday, May the 17th, 2 o'clock Central European time in Cologne, with input also coming from our colleagues at PTV in Karlsruhe, Germany, and from Budapest. And one other point, so you're aware, this webinar is being recorded, so others can refer to it later, and we will make the link available to you also afterwards, so you can share it with colleagues if you would like to. Just before we get started, I'm going to share a few technical components for you. First of all, with the phone or internet connection. If you are connected by internet, that's great. If you're connected by phone, we'd like to recommend that you also make sure to use the audio pin, which should be shown on your panel, probably on the right side of your screen. You can hear us fine all the time, with or without the pin, but if you want to be unmuted and to join the conversation, you need to be using the audio pin. So your default position is muted, just so you know, so you're not adding to the conversation accidentally. Participation tools, we've got a few ways that you can join the conversation. I'll start by saying the mute button is there. That's not really for participation, but again, to prevent participating when you don't intend to, and the default position is muted. If you would like to, you can, or if you would like to get our attention, if you'd like to say something, we have the raise your hand button, and I would just invite you to do that right now if everybody's, just to let us know. Do we have hands going up? Okay. We have also got questions. So if you would like to ask us a question in written form, you can just use the question box, and my colleague Kristen will be addressing the questions as we go along. She'll either type a response to you or share it with the rest of the group during the discussion period, and then we'll address it orally. So those are the two possibilities. And the fourth participation component that you need to know about is the poll tool, and we have several that will be used during the course of the webinar. And when that happens, we'll ask you to respond. They're all multiple choice questions, and we'll ask you to respond to the poll questions so that we can share information with you or about you with the rest of the people that are here today. And just so you know, there are, I think, 50 people registered for today's webinar. So we have a good crowd, and you have colleagues across Europe listening to you, or listening to us today. I would also like to introduce to you the team that's working on this today. I already mentioned Kristen, who is our question and poll manager, who is in a different room from me because she's probably typing answers to you at different times as we go along. I also have my colleague Cyrus sitting across from me because he's managing the camera here, and he's smiling just the same as he is in that picture. And as I said, my name is Bonnie, and I'll be moderating this session for today. Just to put this in context, we have this Flow webinar and e-course, or this Flow webinar is part of a series of 3 that we're offering, and it's the second one, looking at transportation modeling tools, and a third one will be following at the end of this year. And an e-course will be starting next week, which we'll share some more information about a little bit later on today. What you can expect. Point 1, welcome introductions, webinar participation tools. We can check that off the list, that's been done. I will give you a short introduction to the Flow project, and then we'll bring in our first speaker, Eugen from PTV, who will talk about microscopic and macroscopic modeling within the Flow project. We'll have a few minutes for questions and discussion after that, and then we'll bring in one of our project partners to give us an example of what's being done in Budapest with a bike share system that's integrated into the macroscopic public transport model there. And the last component will be assessing the impact of walking and or cycling measures on a city. And this is the impact assessment tool that's been developed within the FLOW project by our partners at PTV. And after that, we will have have time for some more questions and to wrap up. And as I said, we'll be done at 3:30. Just a brief introduction to the FLOW project. So what we're doing and why we're doing it. Some of you I know were in Munich with us a couple of weeks ago, and so you've seen this picture, but for the rest that haven't, looking at the benefits or also the co-benefits of walking and cycling, we're aware of health benefits, environmental benefits, economic benefits, and we have tools to assess all of those things. But the one thing that has been lacking, we found, or was lacking, was assessing the transport benefits of walking and cycling because, of course, they're transportation modes. So the intent of them is transportation, and also then what is the benefit of them with regard to transportation, and particularly with regard to their ability to reduce congestion in a city. So this is what the task is that FLOW has taken on. We like to say this is our story, bringing two worlds together. We have, and I'm guessing probably at least some of you are, transportation modelers who are here, and transport modeling is taken very seriously, predicting and providing future transport needs within cities. So the model says we need a new highway, and a new highway may be built. I know that's simplistic. Our idea is the model will say we need a new bicycle route, and a bicycle route will be built, or walking facilities. So we have transport modeling, and we also have the cycling and walking world, which I think everybody accepts are playing a larger role in urban transportation, but there hasn't been a real connection between what's modeled and walking and cycling, or walking and cycling haven't been modeled very extensively, and this is what we're trying to bring together to see what their role is within congestion. And to do this, we've brought our two worlds together, which we would say are particularly PTV on the technical side with the modeling, and also the European Cyclist Federation and Walk21. So the key European and even worldwide organizations working on walking and cycling together with modeling. This is the first time these two elements have been brought together. So together with our consortium partners, we've also added 9 exchange cities, 25 follower cities, market forerunners who are mostly consultancies who are working in transport modeling and planning, and 25 market associates. And I know that quite a few of you are here today as well, and we're happy that you are. So this is what the whole group looks like that's working on FLOW, and you can see the 6 cities there, and Budapest is one of them that we'll hear from in a little bit later on in the hour. The challenges that we're facing as a project are, first of all, defining pedestrian and cyclist congestion, which is a little bit different, or it's quite difficult to do. It's not something that people consider necessarily. So walking and cycling in the context of congestion. And we spent a long process developing a definition of multimodal congestion. We've also got the question of lack of data, and we'll come back to this again later on while we're in our conversation today, and it's an ongoing topic for walking and cycling. We also have the fact that modeling human behavior simply isn't easy. So a technical tool like a transport model and human behavior, putting them together, it's a challenge. And Eugen and Nora will probably talk about that a little bit more as we go along. We also have the idea that proving that congestion reduction is caused by walking or cycling measures is also difficult. So we're using the assessment tool that we have within FLOW to do that. And also the cultural aspects, I would say the last 2 points, a bias towards motorized transport and often the lack of political understanding and support. And these are components that we're also working on within the FLOW project, not something we'll focus on today, but it's information that we're happy to share later. And I'll just move on now to tell you who will be presenting here today. So we've got, first of all, Eugen Hilberts, who is from the PTV group, as you can see there, and he is a trainer for modeling within PTV, and also a trainer of trainers. So we've brought the experts in for you this afternoon. And following Eugen, we'll have András Koris from BKK, Budapest Transport, and he's an innovation planning manager, a project manager responsible for EU research projects and for transportation modeling. And finally, we'll have Nora Szabo, also from the PTV group, and she's a civil engineer and transportation planner and an international project manager working in the research department of PTV. So these are our Flow project colleagues that you'll be hearing from as we go along over the next hour and a half. I'm going to pass the screen over to Eugen, but just as I do that, I would like to put out our first poll question to you, and that is, just while we're switching over, how would you rank your own modeling skills, with 1 being a beginner and 5 being an expert? And I think you should see the question now. Kristen, are we getting responses?
Yeah, we have about 60% now have voted, almost 70. We will give it just a couple more seconds, 75%.
Okay.
All right, 86%, 89. Okay, I think we can close this out and share the results.
And what do we got then?
So it looks like the answers actually aren't written here. It's only the numbers. For some reason,
the first one, the
yeah.
one is no experience, and the 5 is an expert. So we can see.
I see. Yes, yes, of course. Yeah. So most of them are beginners, actually, and actually a decent amount are experts. I mean, 4 is the next highest amount, 25%. So we have around half who are beginners.
Okay. So Eugen, you know what you're dealing with then?
Yeah.
And with that, then I'll pass it over to Eugen, and we'll give you the screen.
So now, okay. So hello everybody. I hope everyone can see now my screen. Get some of you response. It is working good. We're talking about, first we have 2 parts. The first part is about microscopic modeling and what happens inside the flow project, and the second part is about macroscopic simulating. I would start with first with the microscopic part. What is inside? We are talking about WisSim and WisWalk, interaction between vehicle driving and pedestrians. We have this enhanced modeling of conflict zones between cars and pedestrians, which is very important even in this flow project, because we are talking about exactly those interactions between different ones, different behavior parameters and new mobility patterns. We are talking interaction of bikes and pedestrians, which is exactly in a few of cities one of the goals, I would say, for the reducing the congestions in the cities, and also possibilities of shared space. Before I start, there is also a brief overview about those things which are important to have, and what we can say, what are the data sources of microscopic simulation, and maybe all the questions about that. What is possible for you? What do you have? The kind of ortho photos, for example, or site plans, like we have it here on this particular picture. So we have some vehicle observations for different things, videos for analyzing the driving behavior as well as the walking behavior. Do we have a basis of national or international databases, scientific studies and research projects? That's one of the parts we need in the very beginning, so we get a brief overview what is possible there.
Eugen, before you go on, can we ask another question here?
Yeah.
We won't show it just yet. So the question, I'll tell you what the question is first to everybody, please. We're going to ask you, so if you look at these 5 things here, the question is, how many of these listed data sources for microscopic modeling do you, participants, have available for you in your city? So just look at these. I'm asking you to look now because they'll disappear. Exactly, here's the question. So how many of those do you have available to you in your city? So you have none of them? Do you have the research studies? Do you have orthographic data? Okay.
Okay.
Eugen, can I ask you to, how are we doing with the votes, Kristen? Are they coming in? I was going to say maybe Eugen could read out the 5 options that we had there. That will help people to respond.
That might be good. We have around 60% right now.
Okay. Eugen, can you read those out again?
I can't. No what? Sorry, I can't read something.
You can't see your screen either, of course.
Yes, because I have my screen at the moment, so I can't see the results.
Okay. None of us can. We'll have to make sure and get a good look. So it was orthographic data, I know. There were international research studies you talked about. What were the other ones? Okay. We'll have to go in your memory, I'm afraid. Sorry about this. I hope we can get enough responses that way. And Kristen, what's it looking like?
We have 76% right now.
Okay.
And it seems to have leveled off at that, so
yeah.
We can close it and share the results. So most participants had 2, at least 2. 43% had at least 2. 18% had 3. 11% had 4 or more. So everyone seems to have at least a couple. Yeah, most.
At least one person there that has nothing, it looks like. So it's
yeah,
useful information to know then, yeah, what's necessary still. Okay. Go ahead, Eugen. We'll turn it back to you again.
Okay, fine. So we see it's, yeah, for some it's easy to get this data. For them, it's a new task, maybe to get some data organized, because it's more or less not possible to grow up a model, and yeah, asking for all those things, you have to do a lot of work behind. Let's go more to the details now of VSIM, only to get a first overview about what we are talking about. Is we have a model which shows us typical elements of VSIM, like a link, like vehicle inputs. Connectors, we connect different links. So you see the model is based on a link structure, which includes the possibility of walking as well as for driving. Everything we define in this model is really, or has to be done exactly in this mode. Means whenever some possible area is, so if it is for bicycles, for driving, if it is for cars, if it is for pedestrians, for walking, we create something like a link, like a connector. And we have to manage always all of the conflict areas. So whenever we are talking about conflicts, we have to manage this in conflict areas. So the program is doing more or less nothing by itself. So this is something the user has to do it. Up to the moment that we have, for example, reduced speed areas because of a movement for vehicles. It's clear the vehicle turns around somewhere, has to reduce the speed. For us, it's clear, but not for the model. Though something we should implement into the model, though the model becomes clear. In a special part now for the pedestrians, we're talking about also pedestrian areas. So as we can see here now, we had also a big pedestrian crossing here, which crosses 2 links. One link in one direction from east to west, the other one from west to east, so it's right-hand traffic here. We have a pedestrian part, which is a pedestrian crossing. The whole simulation is in front of the University of Applied Science here in Karlsruhe to demonstrate how students are crossing the street. The rise up of this link here for pedestrians is around 14 meters. That's perfect for the pedestrians. It's more or less not perfect for the car drivers. You know all these problems. What happens if a car approaches here to this pedestrian crossing? Where to stop if you have 14 meters shared space here now? How can we do it? You see here we have this element connector, which connects our links because we have different sizes here. We have some route descriptions. The yellow one is for the big yellow one is for the cars, for the vehicles, for all vehicles, means also for bicycles. And the small line here in yellow is for the pedestrians. So pedestrians have only an origin and destination. They do automatically shortest path search from origin to destination. because of some effects which are inside this pedestrian area. When you have written up your model completely, it will be clear that we have to do a lot of calibration things. The first thing is we got a picture in the default settings of VisSim. And for the default settings of VisSim, we had exactly this picture as a result. As we can see here, we have walking pedestrians, for example, and we have driving cars, and the car stops in front of this whole pedestrian crossing, the 14 meters area, and they do stop there. That's not exactly realistic. So in the realistic way, if you make an observation, and there is important to have some video observations for that, it is important that we see, okay, the car, for example, this white one, comes into this pedestrian area and stops somewhere, wherever a pedestrian is crossing. If pedestrians are crossing here, for the white vehicle here, maybe drives in this pedestrian area and stops only here, but not in front. They do not stop there. So because of this this point, which has been before realized in VisSim, we have changed this, and it's now possible to avoid the blocking of the major flow. And as we can see here, as one of the parameters in this column here, avoid block major. This is tagged on, so means if the option is enabled, all the vehicles, they stop before, and because the major flow, which is here the pedestrian, they have the priority here, though the vehicles give way for the pedestrians here, and because of that situation, they stop in front. We can change this now. This was one of the developments we have done also for the VisSim inside the Flow project, which seems to be very simple, but was a lot of work to change the driving behavior behind those vehicles, which is exactly simple to describe, but not simple to realize. But we have done it, and we have now this situation, which is different. The same, more or less the same time, and we see the pedestrians are crossing somewhere, and you see that the vehicles are inside now suddenly. So means because we have now disabled this blocking the major flow, though now the minor flow, the vehicles can drive in wherever a conflict is. So we had a lot of conflicts now, but there is no waiting in front and up to the end that the car can pass through. That's one of the biggest developments in VisSim, and really makes fun now to develop those in models. It becomes more realistic and see all these possibilities also in realizing that. Okay, that's about the microscopic simulation part. So I go to the macroscopic one. First I start my new one. I'm sorry. Click that and start the, no, that was the same one. Beg your pardon. Take it 2 times and it is the correct one, so now we have it. Here we are, so the macroscopic part. Yeah, we switch a little bit now. Microscopic is clear. You see, we have vehicles, we have pedestrians, we have bicycles. Everyone can drive from origin to destination, no problem. It's like in the reality. Most of the people can realize what happens in a microscopic simulation. The more problematic part in realizing what happens is the macroscopic part, but this is the system we have more possibilities because we can really have a plan what happens in the future. For that, we have also some overviews, some strategic planning, which is behind the macroscopic part. We are talking now VisSim. Macroscopic modeling, walking and cycling in transport is always possible. We can develop whatever you like to have as a change in your network, a development in your network. For example, a shortcut somewhere in the network, or see some detours which are available at the moment. Maybe you can solve for the future, even for pedestrians. It's very interesting to have a detour analysis in the network to see, oh, well, we have some gaps in the network. We can solve these gaps, and using vSim as an analyze tool exactly for that. Yeah, the data sources for this one is, again, we should have some GIS data, like networks, including land use, which gives us more information about the situation. Maybe one uses OpenStreetMap data, other one has own GIS, will be one of our questions. Then we need a demand, or we have already a demand model behind, so you have one. If not, we need social economic data of a city. We need some surveys, household survey, roadside interviews, something else, traffic data from counts, for example, to calibrate our model later. That's very important to have a calibrated model, like in the microscopic part. And again, we can go up to the national, international databases, for example, as we have it here in Germany. We have the mobility in Germany as one country-wide research for that, and also some scientific studies and research projects for that.
Eugen, I'm going to jump in again with the same question. The same question as we asked about the microscopic modeling. We won't show the question yet. We'll give you a moment to look at the 7 points here. So the question is the same one to everybody. How many of these 7 listed data sources for macroscopic modeling do you have available to you? We'll just give you a second to look at this and count. Then we'll show you the question so you can, you know what you're answering. So you can see it now. Okay, Kristen, I think we can show the question now. So there you go. For your city, how many of these do you have available to you?
Okay, we have 60% have come in already.
Okay.
In the meantime, while we're waiting for these to come in, we got a comment from Robert Stosi. He said that actually the challenge is that in some neighborhoods we have lots of data, and in large parts of the city we have much less data. So that's an interesting point to raise, yes, that even if this data is available, maybe not for the entire city, only for certain parts. Okay, at this point we have 87% of the people who have voted, so I will close the poll and share the results. And it looks like, yeah, 44% have 3 to 4 sources, just 3% have none, 21% have 1 to 2, 21% have 5 to 6, and 12% have 7 or more.
Okay, interesting. So you can all see where you stand among the rest of the groups, the rest of the cities that are represented here. So it seems like quite a few have 3 to 4. That seems the highest number. Okay, we'll give it back to you now. See if that's useful information for you as well as you go on.
Yes, it's nice if we have already data. Even the quality is exactly one of the big questions afterwards, as I know from several projects. When we go through and we start up and then get the people, they said, yes, we have all this data, and we have a look inside, and okay, this is the data from 1995 or something else. So it's not the newest one, maybe. This is one point. The other point is maybe if you have some traffic counts, even if you have loops or detectors on the streets or something else, maybe they do not work properly, and so on and so on and so on. There's a lot of problems sometimes, and we should talk about the quality of this data, which is really sometimes in the worst case. Also of the network by itself helps nothing at the end. We should develop our own network and correct it, because what we like to do is we like to give a simulation of the reality in our models. It means our model as we have it here, for example, now, it's a very small model. It's we call it a Visum Island because we have only, yes, small region here where we can talk about it. 4 zones, 4 cities, but we can talk about all of those things, which is different now to the microscopic modeling. We have a macroscopic modeling is a link and node orientated model, like we know it from statistics to find the best path from origin to destination. And origin and destination search is based on a Dijkstra algorithm, and find out which is the best tool. For creating such a network, we need, as we can see here now, some links and some nodes. You see the blue crosses, these are the nodes, and we see the links which are in colors because we have some classification, as we can read here in our legend. The blue one is a state road or country road, and the yellow one is a municipal road. In the middle, there's a rail. I think this is easy to understand. And this one here maybe is a kind of a river. It's also possible to simulate some other, let's say, other vehicles. It's not only a street-bound or road-bound vehicles. You can also simulate water-bound vehicles. You can also simulate aircraft, what is also done in some several projects. Background information also a little bit helps us to understand the map, also to display it. The big difference between micro and macroscopic modeling, if you present results, it's only a map. And we should make the map easy to read for people that they are not looking on a, let's say, the sewing map. Because, yeah, if you don't describe or you don't work with colors, helps more or less nothing. To have our demand located, we need some zones. We have now here 4 cities. This is a village here on the top left corner. Here in the center is Bay Village. Here we have number 3 Sea Hamlet and 4 X Town, and we like to talk about the traffic between those cities. One example is you've split a village in 4 parts now, and said, okay, to make the analysis a little bit more realistic, we need smaller zones, maybe not for the demand modeling, but for the real assignment later. We like to assign all the demand, all trips, they are produced somewhere from an origin and goes to a destination, for example, from one of these particular zones here inside, 7, 8, 9, and 10, and it's going up to 2 or to 3 or to 4. So what we do is we will do an analysis. That we can do this analysis, it's important to have some connectors. Connectors connect our zones with our network. We can have multi-connectors. We can have only one connector, like here in this example, to share the trips. Though everything starts now here, that's a representative node of this particular zone here, for example, of zone number 7 or of zone number 8, and so on. And I can make now an analysis exactly. A trip starts here in this particular zone, using the connector, going through the network, searching the shortest path up to this point here, and entering the zone there. That's what is behind. We need to model some demand, so the demand is always stored as a matrix. Let's have a look for the matrices now. In this particular project, we have, as an example, we have 3 matrices. We have a car matrix, which shows us a car trip from each zone to each zone. We have a matrix for HGV, for trucks, which shows us the truck trips here. And we have also a public transport matrix, which shows us the public transport trips per person. Well, here we have vehicles, cars, and HGVs. Here we have passengers. They are willing to have a trip from origin to one destination. This demand is a result in a regular case of a demand model. It's not possible to use survey data and rise up to project survey data to a total number. I will tell this because I know this happens sometimes. That's not the case. It's not possible. We can use the survey data only to rise up and to calibrate a demand model. And then result of the demand models are different matrices for different trip purposes. Let's say car driving, bike riding also, as well as pedestrians, belongs to the model size we have. If we have now this particular result of demand, it is clear that we should assign the result to our model. To assign the result to the model, there are a particular different one assignment procedure. The assignment procedure, which is based, the background is more or less always a Dijkstra algorithm, the short path calculation, and we can go through different ones. Let's make one Or yeah, one popular assignment procedure from the new developments also for private transport. In private transport, we are talking about equilibrium assignment from Luce. Luce is meaning linear user cost equilibrium. The Italian way of speaking Luce is, yeah, it's an honor to the chief developer of this part, or the, yeah, let's say the chief developer. It's Guido Gentile from the University of Rome, who has developed this kind of equilibrium procedure, which is based on exactly linear user cost equilibrium, and fulfills the first and the second principle of Wardrop. And it's very fine and a very good possibility to assign private transport to a network. For the public transport, we need also something similar. So we have in public transport, we have we use a timetable-based assignment. Timetable-based assignment, that's what all of you are doing. If you make a shortest path search from your home to another city, for example, you open a timetable information system on your computer, maybe on your mobile phone, and say, okay, I like to start here, and then I go to there. You give maybe a time slot, you open a time slot and say, okay, inside this time slot, it should be possible to trip there. Then you make a choice out of that, and say, okay, I reduce it now to only to those trips, so you have less than one transfer, and so on and so on. At the end is also important what is your personal impedance, your perceived journey time. And we see here we had a lot of different impedance factors, like the in-vehicle time, as well as the transfer waiting time, or the number of transfers, which has an influence to exactly this shortest path search or in timetable-based assignment. After that, we assign those things, and we go to the results and see how many people in public transport have done this. Now comes to the achievements inside the Flow project. We are talking about sharing systems, whatever the sharing system is. It can be a bike sharing system, it can be a car sharing system. What we use, that's an add-on, that's an additional system where we can use in our network. And inside the network, for example, to have some short trips between different points of the network. For example, here we see the red squares, and these are sharing stations. And inside the network, the sharing station, you can have a trip. Here we have the city bike system that people can use to public transport first, up to, let's say, a station somewhere in the city. Then they can switch directly to sharing station. They can take a bike from there and then have the last mile or the first mile. Both are possible up to their home, to their destination, by using one of the bicycles. As we see, a lot of sharing systems we have in this network here. For example, there are 13 different ones. We see the capacity of each one, and at the end we also we can see the occupancy and the rentals in total, how often it will be used, and that's some possibility to analyze the capacity of, or the needs of one particular sharing system. Means if you develop something that, okay, if I implement something which is really which has a high or I really like to have a high effect for the network, we need maybe more, we need a higher capacity, and so on and so on. You see, because of the rentals, we can see where we are going to. We can plan now for the future what is possible for exactly those things. When we have done now all those results, we have done now or we put in all those data. We have the sharing system, we have the public transport, we have the stops, we have implemented, we have the links, we have the nodes, and we have our demand calculator. We have a whole transport model behind. Maybe that was one of the best things we can do. We have a real transport model. Then we also get a result, and the result can look like this. So we have now some volume bars here, as we can see. From where to where. We can have a look to the results. Here we had the darkened blue, which are trips in HGV, so truck trips. So we had some darkened blue which are very less here inside. We had the volume of cars, which is the light in blue. We had the bus and the train system, which is in yellow colors. And to see what happens with the sharing system, our city bike system, we see the red one and see, okay, yes, people share exactly here between. Some are also using the long distance. And if you are talking about long distance, yeah, that's from A village to B village, it's around 8 kilometers. So that's really a long distance, and we see, okay, some of them are using it. Maybe it's higher attractiveness or less attractiveness. If we have to less, we can change something. That's why we construct this model, why we build up and rise the model. It will be nice to have those ideas and inputs for all of the cities, although in the Flow project. So maybe together we can do all of them new developments and see what happens in the future in macroscopic as well as in microscopic modeling. Okay, that's about the situation now. I will say thank you for that, and we have now some minutes for discussion and for question and answers.
Yes, Eugen, thank you very much. I can see there's already one question, I think, coming up. Kristen, what have we got?
Yeah, that question was actually just about whether Eugen could enlarge the data that he was showing. So if you could make it a bit more visible, because the borders were very wide, I think the text was maybe a bit small. That's all that was related to.
Okay.
Not inside the presentation is effectively not possible, but we can do it in a model. But therefore, I should open the model, that's which I do not have now at the moment. It takes me a minute to show it in the model directly.
Yeah. Well, if
the presentation available afterwards, yes.
Exactly. Yeah.
Right.
Good.
Mm-hmm. Yeah.
Were there any other questions came out, Kristen, or does anybody want to raise your hand and ask a question either orally or type a question in?
Yeah, we don't have any other questions yet, but feel free to raise your hand or type it right into the chat. You can ask it, and then I will ask it verbally for you. Okay, we do have one, and this is from Cyrus. Which impedance factors, for example, elevation, cycling lanes, etc., do they use for modeling cycling?
In the macroscopic part or the microscopic part?
Micro, I think he wants.
A macro, he wrote.
Okay.
Macro.
Yeah, because I mean, we are talking about impedance. Most it is macro, but it's not exactly clear. That's something we can define directly. You can say, okay, we have one transport system, which is a bicycle. We can also have some influences between different transport systems or vehicle classes. So it's possible to see, okay, bicyclists don't like to drive on a link, on a particular link, which has too many trips by cars or by HGVs, for example. Yeah, so I do not prefer a link where you have a lot of HGVs. Therefore, we should have the assignment results before. That's the kind of modeling we do, and then it's possible to put in some impedance factors. Shows us for bicyclists that the impedance rises up if one particular link or one route is more or less not blocked, but a lot of other vehicle, cars, HGVs as well are using it. That's possible.
Okay,
Thank you.
Anything else, Kristen?
No other questions and no hands raised at this point.
Okay.
Then I would say thank you, Eugen, and we'll move on. If anybody does come up with questions, we'll have another round of discussion at the end. So there's still opportunities to ask Eugen questions if you would like to. Meanwhile, though, I think we'll move on then to Andras, who is our colleague at BKK, so the public transport provider, operator in Budapest, and he's going to give us an example of the integration of a bike share system into public transport macroscopic model in Budapest. And we should be switching over to Andras' screen, I think.
So welcome everybody. Can you see my screen?
Yes, indeed.
Okay, and yeah. So welcome everybody. I will talk about our experiences regarding macroscopic modeling and bike sharing and cycling. I've also prepared a question for you, so I would be happy if you, Christine, can raise the question.
Yeah.
Yeah.
Should come up right away.
So that is, which of the following does your city have? So does your city have a public bike share system, a macroscopic transport model, both of the above, or neither of the above? We have some votes coming in now. We're up to around 40%, 60. Give it a few more seconds.
Yeah. Depending where people work, it may not be a question that they can answer either if they're not working for a city.
Okay, we have 82%. It's leveled off there. So here are our results. We have 22% with a public bike share system, 19% with a macroscopic transport model, 41% with both of the above, so that's the majority, and 19% with neither of the above.
Okay, there's something you can work with, Andras.
Yeah, I think it's a really good result. So it's better than I expected. It's good to have a lot of cities who has macroscopic modeling and bike sharing together. So I hope that my slides will be useful for them as well. Yeah, and to use my first slide. So basically in the Flow project, we are working on the evaluation and the impact assessment of our public bike sharing scheme. And of course, there are a lot of related infrastructure investments like bike lanes and contraflow cycling in one-way streets, which we would like to evaluate. Of course, we use a macroscopic transport model for these tasks. Our model was prepared between 2012 and 2015, so it's a quite new model, and it's an integrated one. Basically, it was made for larger infrastructure projects like metro lines and tram lines, or larger public transport investments. But it includes also taxi services, cycling, and walking. However, the cycling layer originally was very weak in this model, so that's why we decided to join the Flow project and to improve the cycling layer of our model. For first, we had to collect a lot of data, because without data we cannot model. We have annual traffic counts for cyclists in the whole city at 62 cross sections. And last year we've carried out a quite large household survey based on which we can define new mode choice model parameters and calibrate our mode choice model. We've implemented some loop detectors in the city, which provides us 24/7 continuous traffic data about cycling. And also last year and this year we joined the European Cycling Challenge, through which we can collect really valuable GPS data and to analyze the most popular cycling routes in the city. And of course, we have the origin destination data from the backend of our public bike sharing scheme, which is necessary to model our bike sharing scheme. After collecting all of this data, we've started to improve the cycling layer. So first, we started to optimize the route choice, which means that we added the elevation to the impedance function. And currently, we are testing different types of assignments like equilibrium and stochastic. What is really important is that we made an independent scheme matrix for cyclists, which makes mode shift possible from car or public transport to cycling. After having this improved model, we will be able to evaluate the impact of our infrastructure projects in the city. The other large part is the concrete integration of the public bike sharing stations and the scheme into the model. The integration of the stations already happened. We have more than 100 stations in the city, and we've ran tests during the last summer with the beta version of Visum 16. We still have to make some optimization because we have a problem with the running, but this year our model will be ready and we will be able to analyze the further extensions of our scheme, which will be very useful for us. I tried to collect those key issues regarding macro modeling for the cities who would like to start now macro modeling. The first two things, like convincing decision makers and find financial resources, could be done easily if you have if you are eligible for EU funds, because for larger infrastructure projects, the EU requires macroscopic modeling. So in our case, it was the same. We could make the baseline model, the large macro model for the city and its agglomeration by using EU funds. After you have the financial resources, of course, you have to procure a robust hardware and software equipment. And in my opinion, the most important is to procure really reliable and good quality data and store them in an appropriate structure. Based on a good database, it's much easier to build a robust and reliable model. And of course, you have to have trained experts, and it's always worth to use well-developed analysis methods, which are good and have been previously by other cities and companies so far. So that's what I wanted to tell you in very brief. If you have any questions regarding our experiences with modeling cyclists in macroscopic scheme, you can write me an email, or you can raise your questions right now or afterwards.
Okay, we do have two questions that came in. And the first one is, are there any pedelecs among the bikes, or maybe any plans to add pedelecs if there aren't already?
Actually, we don't have pedelecs in our scheme. These are conventional bikes. We plan to have them. And of course, that would raise a different modeling question, but currently we have only conventional bikes.
Okay, thanks. And then the second question is, how long did it take for you to digitize your cycling network? Did you separate cycling tracks, for example, physically separated, and cycling lanes, such as lane markings on shared road space?
Basically, the development of the model itself took 3 years for us, but this is the complete model, including the network, including the demand model. So I think just to implement the network itself is not that complicated. The GPS data from the European Cycling Challenge was really useful for us because based on the data, we realized that some routes which are frequently used by cyclists are not represented in our model. So then we added those routes to our model. But the most important, I think, is to find the right route choice and mode choice functions for your model, and for that you need a lot of data directly from the users in most cases.
Thanks. And then just one more question came in. What data can and are being collected in Budapest about the public bicycles currently?
About public bicycles. Okay, we have a complete backend system, so we know all the origin and destination of the rentals. We know the duration, the approximated length of the trip. Of course, this is a calculated length We have GPS sensors in the bikes, but they are only used for emergency cases. But currently we collect data through smartphones, of course within the European Cycling Challenge, and we will collect data within another EU project. In this project we will create a new ICT-based positive incentive scheme for our public bike sharing scheme, and the users will record their trips by their GPS signals. So I think these are the most important data we have about them. Of course, we made last year a household survey, which also gave us really useful information. Yeah, I think these are the most important.
Okay, thank you, Andras. That's all the questions that have come in right now.
Okay. Then also for me, Andras, thank you very much. And we can move on to Nora. So we're going back to Karlsruhe to PTV, and Nora Szabo is going to tell you something about the impact assessment tool that's been developed within the FLOW project. So looking at walking and cycling measures and their impact on cities. So Nora, we can see your screen already.
Okay, it's nice. So welcome everyone, also from my side. Well, Bonnie has already introduced me, so I would just directly jump into the introduction of the impact assessment tool. So, as this name already denotes, the main aim of this developed tool is, of course, to assess a wide range of impacts of various walking and cycling measures, including, of course, the congestion reduction potential. An impact assessment typically consists of three steps. The first one is defining the target system. So this has to be defined in order I mean, only along these targets can the measure be evaluated and also the success measured. And these target system has to correspond to the goals of the municipality. And once these targets are defined, the indicators referring to these target system elements have to be determined as well. And these indicators are basically the leveling rule for success or failure. The third step of this impact assessment procedure is the aggregation of these single calculated indicator results using well-known aggregation procedures such as a multi-criteria analysis, weighted benefit analysis, or a cost-benefit analysis, but also, yeah, to some extent, a qualitative appraisal. At this point, I would like to make it clear that the aim of FLOW was to develop a set of sound indicators, so a full list of indicators referring to the FLOW purposes. So the main aim was actually not to develop the aggregation procedure, not to invent anything new concerning the aggregation, but the innovation was the set of indicators itself. So generally, we differentiate between a socio-economic and the business assessment, and I don't want to waste so much time on that. The developed FLOW assessment corresponds to the first one. This is a socio-economic impact assessment, which is necessary, for instance, to get public funding. In terms of the time, once we are just checking the achievements of the targets, we can differentiate between an ex-ante assessment and an ex-post evaluation. The ex-ante means that we are analyzing and evaluating the impacts of the measures prior to the point when these measures are implemented, whereas the ex-post evaluation means already we are just evaluating it right after the implementation of the measure. And from the politician's point of view, the second one is not really desired because at this point there is no interaction or no change in the plans are possible anymore. So, if we are talking about assessing the impacts, we are always measuring the difference between the with case, which is basically the status after the implementation of the measure. So we are comparing that to the without case, where the measure is not being implemented. These effects are always measured. As you can see in these two screenshots, these measures are evaluated in the whole network, or yeah, with better words, in the determined catchment area. This figure, so we just jump into the 3 steps. The first step, as you may remember, this is the target system definition. So corresponding to the mission of flow, tackling urban congestion by walking and cycling measures, you can see on the top the mobility benefits are staying in the foreground. That means the effects on the transport network performance. But besides these direct mobility effects, we are treating, or we are considering also the further benefits such walking and cycling measure can bring. In fact, we are just handling them on the same level of importance. And these effects are, I mean, with these indicators, we are just assessing the impacts on the environment, on the society, and also the positive effects on local economy, so private business. And since flow is dealing with a socio-economic assessment, the costs of the measures also have to be identified. Yeah, as I just mentioned, in order to get public funding. And based on this target system, and this is the second step of this evaluation procedure, based on the target system, a comprehensive set of indicators was just determined. Whereas, as you can just see it from the color scheme, each indicator refers to a certain target system element. So by the selection of these indicators, the most important criterion was, of course, to be multimodal, since we are dealing not only with motorized transport, but also walking, so pedestrians and cyclists, and besides that also with public transport, and also urban freight, so city logistics. As you can see it here from the list of these indicators, we have typical indicators included which are part of a well-known cost-benefit analysis, for instance, such as travel time or CO2 emissions. But we also have indicators extracting or just bringing them into this tool from innovative tools. For instance, referring to society, the health benefits based on reduced probability of death for people who cycle or walk. And this was an indicator taken basically from the heat tool, as Bonnie just also mentioned. Now we just come to the third part of this impact assessment tool, and this is the aggregation of these single indicators. So once we have developed these and calculated these single indicators, we are just ready to aggregate them along the following aggregation procedures. So we have different possibilities. The simplest one is the multi-criteria analysis, whereas we are just calculating all indicators and listing all indicators for the with and without case of the measure, and we are just building the difference. We are just calculating the difference. One step beyond this, once we are just aggregating these indicators, we certainly have to have the same units for the aggregation purposes. And in order to do so, we have to transfer these indicators into utility points with the help of an adequate utility function. One must say the disadvantage of this aggregation is that there is no indication of the efficiency after evaluating only one scenario. So, for instance, one walking or cycling scenario or measure, which certainly means that we have at least 3 scenarios to be evaluated for a proper weighted benefit analysis. The third of further aggregation procedure is the cost-benefit analysis. This is, I guess, well known to everyone. We are just offering the cost-benefit ratio at the end, and everything is just calculated and discounted to this period. I just mentioned we also have quantitative indicators besides the quantitative ones, which means these qualitative indicators can be the part of the multi-criteria analysis, and it can also be the part of the weighted benefit analysis. But since they are only so they are not quantifiable, this already means they are also not monetizable. That means we also offer a smaller qualitative appraisal, and this can be seen as an add-on to the proper cost-benefit analysis. So after just introducing the theory behind the impact assessment tool, so these 3 steps, let me just show you the steps of the direct application. So first, yeah, you must have, once you have defined the measure, once you have described your measures, you must have done it based on a certain criteria corresponding to the political goals of your city. And these political goals actually already determine the aggregation procedure. At the end of the day, what you just have to implement. For instance, if you're interested in a proper economic analysis or proper economic feasibility, you must apply a cost-benefit analysis. But if you just say, okay, well, I'm particularly interested in the, for instance, the CO2 emission reduction, so just simply comparing the after values to the before values, it's enough if you just go for a multi-criteria analysis. Furthermore, in order to get realistic results at the end, or just to ensure that your assessment makes sense, it is also important that you determine your catchment area as the very first step. Then in the second step, the indicators are calculated, in fact, automatically with the help of embedded formulas within the tool. And all you have to do is at that step is to enter all the required input data for the calculation. And once these indicators are calculated, in the consecutive step, these single indicator values are also aggregated, also automatically. So depending on which aggregation procedure are you interested in, it can be you will receive a result either for a multi-criteria analysis, a weighted benefit analysis, or a cost-benefit analysis. And once we are done with that, once we have conducted our impact assessment, of course, we will get a result at the end, but as a very last step, we have to understand what this result means. For instance, if I just get a result for as a cost-benefit ratio, for instance, for a cost-benefit analysis, like plus 3.2, what does that mean for me? Is it good? Is it bad? I'm telling you this is good. But for instance, if you have a number smaller than 1, or if you have a negative difference, for instance, if you're comparing the after case to the before case, if you get a negative value, what does that mean for you? And also not but not least, once you have identified the result or just assessed the result, you may also be interested in the so-called sensitivity analysis. So at this point, we are just analyzing which indicators have the most impact or the highest impact on the measure.
Nora, before you go on, we talked about a question that we wanted to ask here as well. If we can put the next poll question up, just to know who has actually used such procedures or processes in your own cities. So here's the next question we have for our participants.
Good. So what processes have you used to evaluate walking or cycling measures in your city? Have you used multi-criteria analysis, weighted benefit analysis, cost-benefit analysis, qualitative appraisal, or you've never evaluated a walking or cycling measure?
And you can choose as many as apply this time. If you've done them all, then you can check all, or then you can check all 4.
Yeah. All right. We have 70% right now. Almost 80. Okay, it seems to have stalled there, so we can share the results. And it looks like 31% have multi-criteria analysis, 17% have done weighted benefit analysis, 31% cost-benefit analysis, 34% qualitative appraisal, and 52% haven't evaluated a walking or cycling measure.
Okay. Which says that we've got some multiple answers in the first ones, obviously. So some have done multiples of the top 4, and then half of the people here have not evaluated, or cities have not evaluated a walking or cycling measure yet. Is that a surprise for you, Nora, or no?
No, actually not. I was just expecting some kind of this kind of results, because we are also aware of that. This is actually the scope of flow that especially if it comes to cost-benefit analysis, evaluating walking and cycling measures in this perspective, it was not priority 1, so to say, compared to other big highway or railway projects. And qualitative appraisal, I'm also fine with that. I mean, it also makes sense, since we have, once we are talking about the benefits, we have some social and environmental gains which cannot necessarily be quantified. So actually, I'm fine with the result, and yeah, this is exactly the scope of flow to push it also a little bit and to make it easier to apply this tool. And yeah. So this is the result sheet of this Excel-based impact assessment tool. Here you can see the results of the aggregations, like the results shown here, the results of the cost-benefit analysis, the weighted benefit analysis, and also the qualitative evaluation. I'm just showing you this slide, or yeah, just a screenshot from this from the Excel sheet, just as a teaser, because more details will just come in the online learning course. So I don't want to waste more time with that. But still, I think it's important to you just to get an overview about yeah, the single sheets of the impact assessment tool. So on the previous slide, you just saw the results. That is the result of the aggregation. So the result of a weighted benefit analysis, a cost benefit analysis, and a qualitative appraisal, just as a repetition. And aggregation means the aggregation of the single results. And on the other sheets, these single indicators are just calculated, everything automatically. And for that, I mean, all you have to do in this Excel sheet is to provide some input data, or just feed the tool with input data. Here you can see on the top of this page, on this slide, we have 3 input data categories. The first one is the traffic data. This traffic data can either come from the transport model, or it can also come from traffic counts. And also conversion factors. You will just get some information about that also later on the slide. What do mean? And the monetary values, of course, you only require that these types of values if you are just conducting a proper cost-benefit analysis. So now I'm going to talk about the single indicators referring to each target system element. Yeah, however, quite briefly, because yeah, the only aim of this the main aim of this webinar is just to give you some rough idea about the impact assessment tool, and this can also be seen as a as a theoretical basis for the online learning course, because later on in the third module you will just get more information within the unit. You will get more information about each indicator, also about the calculation procedure of each indicator, the input variables, and so on. And besides the online learning course, I would also recommend you to read the guidelines, where everything is explained quite in detail. So the first introduced indicator is measuring the transport network performance, so referring to the direct mobility benefits, and this is the travel time. This is measured, as I just mentioned, this tool is multimodal. The travel time is calculated separately for each transport mode, so separately, and then summed up, of course, for each transport mode in person hours, or once we are also considering freight transport, and for ton hours, calculated in the peak in an assessment period, which depending on the model or depending on the available data you have, it can either be in the peak hours, or if you have a macroscopic model, for instance, it can also be daily values. And then everything is just calculated and then extrapolated to 1 year, to a year period. So this was the basic calculation for the indicator itself, and then this has to be also monetized once we are just applying a cost-benefit analysis. And for that, we have to multiply these actual travel times already in person hours with the value of travel time savings. For that, of course, we need some more input variables, and this is everything. I mean, everything is included in the tool. And for that, default values may be provided. I mean, for the different values of time, the different values of travel time savings. In the tool, everything is quite well denoted whenever there is a need for interaction, or whenever input is needed from you. So default values are provided again, which can be, of course, overwritten if you have better numbers. So it may be a little bit too abstract for you. this is only because of the time, I mean the shortage of time in the, but don't worry, in the online learning course you will get more information about the calculation and also the required input variables. So the second group, these are the selected indicators which are measuring the environmental impacts. So the CO2 emissions, the NOx emissions, and the particulate matter emissions. And similar to the travel times, these direct emissions are also calculated on a yearly basis in tons, and then by multiplying the mode-specific vehicle mileages with the emission factors. And since we are in flow, and since we are dealing with congestion, it was quite important that that the emission calculation also reflects to congestion or the improvements on the traffic situation. And in that sense, we are just calculating the emissions in the 4 traffic situations, and we are providing emission factors for both for all 4 traffic situations. This is the free flow. I mean traffic under free flow conditions. In heavy traffic, traffic under saturated conditions, and stop and go. And of course, we are also we can also apply the cost of emissions, and then we can assess. I mean, then the indicator will directly feed into the cost-benefit analysis. Yeah, the indicators referring to society are the number of casualties, of course, before and after, so with and without the implementation of the measure, also per year. So the number of killed persons in a fatal accident, the number of seriously or slightly injured persons. And besides these indicators, as I just mentioned, an innovative indicator is directly coming from heat. From the World Health Organization, and this is called the health benefits due to the reduced probability of death. The only modification, I mean, this calculation, since the indicator is taken from heat, from the heat tool, also the calculation procedure directly taken from heat is also embedded in the flow impact assessment tool, with the only modification that we are not applying the value of statistical life, which can be found in the heat, I mean on the homepage, but we are just applying the cost of fatalities based on the heat code database, which are also applied for the killed persons and the other accident types. And this is because we wanted to maintain a consistent assessment. So we have well-known indicators referring to local economy or private business, such as the vehicle operating costs and the final energy consumption. But besides these 2 ones, we have again some innovative indicators, and they are the residential and commercial attractiveness. Similar to the emission calculation, the final energy consumption is computed in 4 traffic situations and then summed up. And the commercial and residential attractiveness, they are just calculated by estimating the value uplift of the surrounding buildings in the catchment area of the measure due to the improvement of such, for instance, such pedestrian measures, improvement of the pedestrian environment through the measures. So far we have talked about the benefits seen as cost savings between the with and without case, but the end users, for instance, the municipality may be also interested in the costs that are directly linked to the measure. So by, for instance, building a new infrastructure element, and in order to get the full picture and also to be able to conduct a proper cost-benefit analysis. Therefore, the investment and operating and maintenance costs are also calculated for the flow purposes. Whereas your own cost estimates have to be entered in the tool. However, default values may be provided for the interest rate and also for discounting. Actually, until this point, I was just talking about the quantitative and, in fact, the monetizable indicators. But I just mentioned in the beginning we have 3, as you see, altogether 3 qualitative indicators. they are referring to the environment, so the sealed surface in terms of total new or deconstructed traffic area. And we have two indicators such as the accessibility, so the increased access of non-motorized citizens to different amenities, and the separation effect. They are assessed on a qualitative manner, and they are referring to society. Yeah, here you can see a basic, some sample calculation. Here you can see the scaling for that, starting with -2, meaning a great negative impact of the measure on the current situation compared to the situation before, and 2 means this is the best. The measure has a great positive impact. Further information, also the exact explanation of this scaling, and also the explanation of all indicators, boundaries, and all the calculation procedure can be found in the impact assessment tool guideline. So once we have all aggregated and calculated the indicators, we are just ready to interpret the results and just get the final results of the project appraisal. And as part of this sensitivity analysis, we have to identify the variables which have the largest impact on the project, and they are typically the travel time. Also because of the fact we are just calculating them on either on a peak hour basis or on a daily basis, and we just want to extrapolate them onto a year period, which means even a smaller change may have a huge, larger effect if you're just considering already the time frame of 1 year. The other indicator which does have a huge effect on the assessment overall, this is the saved human lives, for instance, just because of the fact that we are considering the money. We are just transferring them expressing them in monetary terms, based on also the willingness to pay. This can differ from society to society, from country to country, but even one saved human life may outweigh the whole, all other indicators, exactly because of the values of statistical life. And this is also the danger and the fear in an assessment procedure, because sometimes it's quite difficult to make the direct link between a saved human life, for instance, and the walking or a cycling measure. So this could lead to some underestimation or even overestimation of the effects, and it may also cause some uncertainties at the end. So this was basically all what I wanted to tell you now. Here as a last slide, you can just see what will happen during the online learning course, and this is exactly the application of this tool. In fact, to a use case in Lisbon. Lisbon is one of our partner cities, and the tool will just directly apply to a measure, to a case study in Lisbon, and then you will just receive an example and a task for that, and you will just be able to conduct a proper assessment procedure for that. Yeah, and just talking about the online learning course, at that point I'm just handing it over to Kristin, and he will give you some information about it. Thank you for your attention.
And thank you, Nora, very much for that. Kristin, you want to just go ahead with the e-learning stuff? Nora's mentioned already what's coming. You can explain how people can sign up for it.
Yeah, absolutely. So I will share my screen. Okay, and I hope you can see it. Yes, I trust you do. Okay, good. So basically, this was a teaser for the upcoming e-course that will open on May 22nd, so that's next Monday. It'll focus more in depth on the topics that we've just covered in this webinar, and it will run for 5 weeks, so until June 23rd. The registration process is actually very simple. So first, you would just go to mobility-academy.eu. You click on Create New Account, like you see right here. And then we continue. Pop this back in. And then you just fill in the requested fields and click on Create New Account down here. Then you'll receive a confirmation email. You may have to check your spam folder just to be sure. And then you just click on this link in order to confirm your account. Then you can just return to mobility-academy.eu and log in. And anytime after that point, you can just come to this website to log into the course. So then you click on the Flow folder here. And you'll see that we have a total of 3 courses. So we've already completed 1 course on congestion in your city, the flow approach. But now we'll be moving into this second course, flow and transport modeling, looking at the tools. So you just want to click on that. If you're interested in registering for the 3rd course, then that's absolutely fine too. And we welcome you to register. It's more about the policy context of applying these flow tools. But then once you click on the course, you click Enroll Me. And then you receive another confirmation email. You can optionally update your profile on the platform, but otherwise you can just click on this link, and that is the link that you can use going forward to access the course directly. So this is from the 1st course, but here are the links to the direct links to the courses, and this is also available on the Flow website if you go under Learning and Exchange. So yeah, that's basically the process. It should be very simple, but if you have any questions, then we welcome you to contact us on the contact form on the Flow website, or you should also have Bonnie's or my email available. Yeah. So we hope to see all of you there on the discussion forum and to continue this discussion that we've started here. And maybe you can ask any questions that you weren't able to ask today, and our moderators can help to answer them. So this will be Nora and Eugen who will be moderating the course.
Yeah, so you'll be seeing them or hearing them again next week. We should also say the course runs, you can do it on your own time. So it starts on Monday and it goes for 5 weeks, but you can come and go from the platform at any time. You'll be receiving weekly assignments to do. You can share, ask questions, comment, and then the next time Nora or Eugen are on the site again, they can respond to you. You can also interact with the other participants as well. So, but it works on your own time, so it's very flexible that way. We're basically done. I didn't ask at the end if there were any final questions for Nora before we go. We've got a couple of minutes. Does anybody have anything they'd like to ask before we finish up? Were there any other questions that came in, Kristen, along the way?
No, no other questions along the way. No hands raised. Yeah. Well, there was a very specific question actually just for Andras about the BKK's stated preference survey. Was this survey only about the bike sharing system, or did it cover anything beyond that, was the question that we received.
Andras, are you there?
Andras, if you're, he may not know that he is muted. I've unmuted. Oh.
Sorry, I was muted. Okay. Can you hear me right now?
Yes, we can.
Okay, so our stated preference survey was a complex survey for cyclists and for public bike sharing. So these 2 modes were compared to the choice of other modes, like we raised questions. Would you choose car instead of cycling, or controversially, if some details would change, for example, travel time or costs or things like that. But yeah, we were focusing on cycling and public bike sharing.
Okay.
Okay. Thanks, Andras. And thank you, Kristen. And as Nora said, there's a lot of information that she was giving you. It's relatively complex, I know. But over the course of the next 5 weeks, starting Monday, she'll be able to explain and walk through this tool with you, and you'll see the different pages of it and the components and how it can be used. So it looks a bit challenging right now, but once you get into it, I think it should be interesting, and we hope it'll be a useful tool for cities when they're looking at assessing their walking and cycling measures. So again, thank you to Nora. Thank you also to Eugen with the overview on the modeling, and to Andras with his concrete example from Budapest. And it's 3:30 now, so if we have no other questions, then I think we'll wrap up and say thank you all to you very much for joining us today. Goodbye.